All right, so looking at some conversion examples, so going from radians to degrees and going from degrees back to radians. What I'm going to first say at the top of this, because I just thought of it and I have to remind folks all the time, is that if you're using a TI-84, this also happens in Desmos, but you need to set your mode, that mode button, and then head to radians if you're working in radians. All right, because you do need to set kind of what type of angle measure you're working with, because they're not the same, right? So it will do the conversion for you, but you just need to tell it what you're working with. So first of all, let's look at how to go from degrees to radians. We're used to degrees, so let's start there. So we might have an example of convert, let's say 60 degrees into radians. How do we do this? Well, first of all, we need to know how many radians are in a full circle of rotation. So you might already know the circumference formula for a circle, just coming back here for a moment. The circumference formula for a circle is what? 2 pi r, right? That tells you how long the arc length is around. And this is precisely the angle measure in radians for how much it takes to trace out that much arc length. So we know that 2 pi is really the same as 360 degrees. 2 pi radians is really 360 degrees, and so that tells us that pi radians is really 180 degrees. And so this is what we use as our kind of our converter. All right, so if I want to convert 60 degrees into radians, and what we're going to do is we're going to start with 60 degrees, and we're going to use this tool here. Since this is equal, that means that pi radians over 180 degrees is equal to 1, right? Because these are the same thing. And likewise, this is the same as 180 degrees over pi radians. And so we'll note the units and use them in a creative or clever way to get to the one that we want. So if I'm going from degrees to radians, that means I need to multiply it by something and end up with something radians, which means I want the degrees to cancel and I want to be left with radians. So that means I'm going to multiply by the one that has degrees in the bottom, because then those degree units will cancel and I'll be left with pi radians in the top. Okay, and so what we end up getting then is 60 pi radians over times degrees over 180 degrees, and the degrees cancel. And so you're left with 60 pi over 180. Now this does reduce. 60 is 1/3 of 180, and so we get 1/3 pi radians. But you'll often see this just written as pi over 3. Okay, so this is one of those ones to memorize, actually. That 60 degrees equals pi over 3 radians. These are interchangeable. Okay, so what I'd like you to do is hit pause on this one after I write down the example and say, can you convert, spelling is hard, convert 30 degrees to its angle in radians. All right, so hit pause and try this yourself, then I'll continue. And again, this is just kind of getting your hands dirty. So similar to before, taking 30 degrees, I want to multiply it by something to be left with radians measure. So I'll multiply by the same thing. It's pi over 180 degrees. Those degrees cancel, and you're left with 30 pi over 180, and this reduces to pi over 6 radians. Okay, so here 30 degrees is the same as pi over 6. This is another one to pack away and memorize because they come up a lot. 30, 60, 90, you might remember, is a special triangle, as well as 45 degrees. So I'll say similarly, and you can verify this for yourself. It'd be good just to kind of drive it home. 45 degrees is the same as pi over 4 radians. Okay? So this is converting from degrees to radians. Let's do one more of a few examples of converting from radians to degrees. So going back, maybe you have something in a radian measure and you want to tell this to a physicist or somebody who maybe cares more about degrees. Again, they're more kind of user-friendly for the layperson. Radians are more of the tool than for the mathematician and the engineer. So anyways, let's say we wanted to convert, let's say 7 pi over 3 radians to degrees. How would we do this? Well, we have 7 pi over 3. We know this is in radians. And then I want to multiply it by something so that I'm left with degrees. So that means that this would need to cancel with radians in the bottom and have something with degrees in the top. All right, that's how canceling works. So our converter from before is 180 over pi, because those are the same quantity. And so here we see, yep, radians cancel. We'll be left with 180 times 7 pi over 3. 7 pi times 180 all over 3. Degrees, we can do a little bit of simplification here, that 180 over 3 is 60. So this is really 7 pi times 60 degrees. And this would be, what, 420 pi degrees. And then from there, right, you could just approximate pi. Remember, pi is approximately 3.14159, and get something close to like 1300-ish. All right, I'm going to leave it here because I don't have my calculator totally pulled up. But it would be around there. Okay? So this is how we convert from radians back to degrees. You'd use 180 over pi because that would make the radians cancel. And this is just the process over and over again. So now you can go back and forth.